In this video, we're going to discuss what it means to program on a server rather than locally. The canonical method of teaching programming is to assume that all parts of the program, including the data with which it interacts, are stored on the same machine. This makes it easy to understand data storage and retrieval. It also handily avoids issues with multiple access and other servlets accessing things from over the internet. However, in the real world, many programs depend in some way on other machines. Perhaps they're getting data from an external server. Perhaps they're trying to write to or modify another machine in some way. Either way, programming on a server brings up two potential difficulties: latency and read-write conflicts. Let's start with latency. Basically, latency exists due to limitations imposed by the speed of light. Whereas the time it takes signals to travel within a machine is measured in nanoseconds, it takes a minimum of about 75 milliseconds for signals to travel halfway around the world. In reality, there's rarely a straight line path, and the nodes through which the signal travels aren't instantaneous either, so signal delay might easily be in the hundreds of milliseconds. This also assumes that a server can respond instantly to requests. If the requests require a substantial amount of processing, or if the server is already overloaded, then the latency could be on the order of several seconds. So how do we deal with latency? Well, we can't physically speed up signal transport and processing, but we don't necessarily have to wait around for them either. Depending on the structure of your program, you might be able to design it in such a way that the machine sends a request to a server, does something else while it waits for the request to process, and only later uses the results of the request. If execution times are balanced carefully, the program can run the server request just as quickly as before, but get something else done at the same time. The second issue to deal with is concurrent access. On a local machine, concurrent access is only a problem if the program is specifically designed to be run in parallel. If not, then by default the program will only run on a single computer core and will execute each instruction in a well-defined order. On the other hand, a server can be accessed by any computer in the world. This means that there's a good chance it will occasionally get two conflicting requests at exactly the same time. Dealing with the concurrent read and write requests is an integral part of parallel programming. Depending on the nature of your dataset and the expected types of instructions, you might choose to allow or disallow simultaneous read or write requests. If they are allowed, then there must be some sort of algorithm to decide how they are handled. These are complex issues, and there's no one universal solution. Instead, the best solution will depend on your specification and those of your intended clients. As we move into the actual programming process, I'll reference these issues as they come up and talk about the advantages and disadvantages of all the possible choices.